applications in particular. But I'd like to clarify from the beginning that data center does not necessarily mean these enormous data centers that Google or Facebook or Apple or Naver or Weibo or those types of companies are setting up that requires acreages or hectares instead of square feet or square meters. Those are included, of course. Those types of data centers need filtration, but the bulk of our customers are really smaller server rooms that have critical electronics in them. Those could be at a factory control room, but they could be a data center such as might be at a bank headquarters or a bank branch, an insurance company, any company or organization that has critical electronics that they need to protect from outside air that's not of the highest quality getting into the server room.
Well, I would think so.
Table of contents for today, we're going to have a brief overview of gas phase filtration, then the protecting of critical electronics, the data center equipment that Pure Filtration sells, corrosivity, environmental monitoring, the media, adsorbent media and chemisorbent media that we use in the equipment, the trends that I see in the data center market in Asia, and then some solution scenarios. So Pure Air Filtration operates in many varied industries globally. Today, we're talking about protection of mission critical electronics from failure. Secondly, a big part of our business comes from odor control and gas emission control from wastewater and sewage applications. We also have emergency gas scrubbers for chlorine, HCl, and other toxic and corrosive gases, and then general indoor air quality. But today, again, we're focusing on mission critical electronics. Our business similarly is focused on gases, as we talked about. Solids and particulate filtration should be part of the overall scenario for protecting your electronics in a data center. And our equipment has a pre-filter and a final filter that remove particulates, but that's really mostly to protect our equipment from the particulates. I see some customers in Asia do not necessarily have a strong particulate removal strategy, and some of the particulates are coming into the data center room and they can be quite dusty. Our equipment is effective at removing some of that, but our equipment should not be considered the frontline attack on particulates, and that's something that needs to be built into the general HVAC system. Liquids and mist are a problem, particularly we see that in the water filtration applications that we're dealing with, not that we're filtering the water, but we're filtering the gases that are used in water treatment. So we have standard mist and grease filters on all of our products in those applications. Not necessarily relevant for data centers, but I think it's important if you have our equipment in other areas so that we cover that. Where I'd like to highlight for us is the gases that we operate in, and you can see how tiny these are in the thousands, millions, and billions of microns, that it's much, much smaller. Everybody recognizes the difference between an atom and a molecule versus a dust particle or carbon particle that gets up into the air. So we're talking about gases, and this is what we remove. In the data center applications in Asia, really the most common problem gases are here: hydrogen sulfide, sulfur dioxide, and nitric oxide. Secondarily, chlorine, fluorine, HF, and ammonia, and then certain VOCs or volatile organic compounds. And we have adsorbent and chemisorbent media to remove all of these. And we'll spend some time on that later in the presentation. But these are what generally these molecules look like. And I put here this slide of purple media. This is our potassium permanganate or sodium permanganate media. That's a really nice magenta or purple color And as the media is spent, it changes color, and we're able to see a grayish or brownish material color that shows us that the media is being spent and how much lifetime is left, and we can calculate that. Here you can see how the media is absorbed over time. The color changes. About this time, we need to be thinking about ordering new media for the replacement. And here it's spent and it's time to replace the media. Let's talk a minute about these words adsorption and chemisorption. Adsorption is really much more of a surface phenomenon. So it's important that we have a high surface area on our media so that the gases that we want to remove are taken out and completely removed. But that reaction is actually reversible if there was extremely high temperature or pressure or even exposure to some moisture. Those bad molecules, if you will, can be removed and come back out and outgas into the airflow. Whereas chemisorption is a bulk phenomenon. It's permanent and irreversible. The chemical reaction, that is. So we're focused more on chemisorption. Some of our media is a bit more of adsorption, but chemisorption is what we're talking about today. Protecting critical electronics from failure. Again, critical electronics are most likely considered to be computers or factory automation equipment. The industries that are most affected are data centers, obviously. Again, let's not just think about Facebook and Google data centers, but the factory control systems or critical computers and servers at a bank or insurance firm. Chemical plants are obvious polluters, but they actually generate gases that can corrode their own factory control equipment. Same with pulp and paper mills. Refineries of oil and gas, any mining or drilling. Drilling can release a lot of H2S, SO2, and other gases. Steel manufacturers or rayon manufacturers can generate lots of H2S and SO2, so we need to track those. Wastewater treatment plants we talked about earlier. But then GLAM is galleries, libraries, art, and museums. They don't generate any problem gases, but they bring in problem gases from the ambient air. And if that ambient air has some corrosive gases inside, then it can certainly affect the artwork or corrode the artifacts that are being displayed. Behind the scenes also, at a museum, there are a tremendous amount of storage that the average visitor to the museum doesn't see. And that storage is subjected to the outside ambient air being sucked in through the HVAC system. And so our equipment is used in a lot of the museums behind the scenes to protect it. Those artifacts and papers and precious documents. Here's a good example of corrosion on electronics. A lot of this was started in the late 1990s and early 2000s by a European enactment called RoHS, or the Restriction of Hazardous Substances. The key hazardous substance in electronics was lead, and there was a lot of lead soldering. It turns out that lead was highly strong against being corroded. It's almost impossible to corrode lead. However, it was determined that lead was causing cancer and other health problems for people. So in Europe, lead was banned in electronics, and the electronics manufacturers globally switched to more copper and silver. Particularly copper is highly corrodable when it comes to sulfuric acid and nitric acid that is generated by SO2, H2S, NO2 combined in the air with normal moisture, H2O. And so it's very easy to corrode the copper. The copper then shorts and the circuit dies, and that whole circuit board is dead and cannot be repaired. Here's a obvious one with all of this brown corrosion, but here's one that's less obvious. These whiskers created in here between the soldering from that corrosion there. So what we have to worry about with this corrosion is production losses, plant interruption, accidents, the costly component replacement of getting new circuit boards or getting all new servers or what have you. And then of course, the big one that factory automation engineers are very worried about is unscheduled downtime. These are the problem gases that we see the most. I would say in Asia, it's these top three. That's largely from your own factory could be creating these problems and generating gases that come back into the control room or into the server rooms. Your neighbors could be creating it. In Asia, there's a lot of diesel, cars, trains, others that are polluting the air around your building. A lot of two-stroke engines from motorcycles and tuk-tuks and the like, and all of that is creating these problem gases to a lesser degree, but still important. We see chlorine, chlorine dioxide, ammonia, hydrogen fluoride, and some ozone. But it's really these top three that are causing most of the problems. Here's the chemical reaction here, getting the SOX plus H2O and sulfuric acid with releasing a little harmless hydrogen. And then this is the corrosion with the copper combining with that hydrogen sulfide and releasing a little bit of hydrogen. That's no problem, but here's your sulfuric acid, what have you. Our equipment used in a data center, as you can see, we have small, medium, and larger size. These two smaller units, note that they're on casters, industrial casters. It makes it very easy to wheel them around. These larger units have more of the absorbent media inside and are very heavy and wouldn't necessarily be able to be wheeled around. So we don't put casters on those. These are somewhat more permanent fixture, whereas these can be moved around the data center at will. The sizes: PFU Mini, PFU Mobile, 1000, 2000, and 3000. And next, we'll talk about the nomenclature here, where PFU, package filter unit, the size, and then the number of banks of media that are inside. So you can see it from our PFU Mini, we're talking about a flow rate of 500 cubic feet per minute or 850 cubic meters per hour. So those are the two flow rate parameters that we tend to operate in internationally. It's either cubic feet per minute in the US, cubic meters per hour outside of the US, and still we see some people outside of the US that are more comfortable with cubic feet per minute. So we put both units of measure on our marketing literature. PFU Mobile is the next size up. That's this black one here in the middle. And here is a double, essentially, the size of the unit, approximately 5.5 feet tall. Very nice. A lot of these being deployed throughout Asia right now. And then the bigger units, the stationary units, you can see how they go up in size. The largest now being a PFU 3000. If you need a larger flow rate than that, we'll consult with you and move to a SAH unit or one of our other types of equipment. And we can cover that in a further webinar. But for most of our data center customers, we seem to settle on these 3 units of PFU mini, a mobile, or PFU 1000. And then depending on the size of the room and the level of corrosivity in that room, we may have multiple units here that we move around, and every month or every quarter we change it to a different corner of the room. The corners tend to be dead spots for airflow, and it works very well to keep the overall corrosivity level down when we move these units around and place them at different points in the data center. So let's talk about, how do we monitor the corrosivity inside of a room? This is a sort of a standard product that's used in our industry. We call it a corrosivity test kit, colloquially referred to as a coupon, but I think the word coupon doesn't really give the whole description of what this simple product does. On the corrosivity test kit, we have a strip of pure virgin copper here and silver here. The ISA standard, the International Society for Automation, says that to use one of these corrosivity test kits, we should deploy it in the room for 30 days. And after 30 days, the corrosivity test kit is sent back to our lab. We analyze it, and we determine how much corrosion is on the copper and on the silver strip. And according to that ISA standard, we report back as to whether that is G1, G2, G3, or GX. And I'll get to that in a second. If we jump ahead, sorry, let's stay with this. So this is done every 30 days. Customers could ask us, well, 30 days isn't really enough to see how corrosive the room is over time, or on a daily or weekly or even an hourly basis, depending on the level of bad air that is around. So we've developed what we call the environmental corrosivity monitor. We're on version 2 right now. And here, there's actually a copper sensor under here and a silver sensor under here. It's doing what the coupon or corrosivity test kit does, but constantly and on a real-time basis, so that we're able to see and read what is the corrosivity environment in the room. And you can read here on the copper, the silver, we have 0 right now, which is great, but it could be G1, G2, G3, etc. It also tells us temperature, air pressure, and humidity, which are critical parameters for keeping the room non-corrosive. We'll talk about that in a second. So the ISA standard calls for the temperature to be 22 degrees Celsius, 2120 is also acceptable, without much change here, and try to be as consistent as possible. And we know from data that we've seen, empirical data suggests that the corrosion rate doubles for each 10-degree in change in temperature. So if we can keep the room at 22, but the room goes up to 32, we know that that the corrosion possibility doubles, which is really a large jump. And it's a similar tack with the humidity, that less than 50%. We've had some customers try to get it as low as 30 and 20, but that's not necessary. If we can maintain 47, 48, 49, 50% of relative humidity in the room, that is about ideal. And every 10% increase in room humidity increases the chance of corrosion over time, 6% per hour. So if you have a very warm room and a humid room, the chances of corrosion on the copper or silver is very high. And that's why if we look back here, this device can monitor and tell you the temperature, humidity, and also pressure, and just overall corrosivity of the room by measuring with the copper and silver sensors what kind of gases are in the room. Also, as I talked about towards the beginning, we want to maintain a lower level of particulates, PM10, PM2.5, and others in the room. That's usually done through the general HVAC system. Maintain lower level of contaminant gas. That it suggests that our equipment should be used to remove the H2S, NO2, SO2, and other gases that are in the room. We can also work with the customer to put our equipment into the air handling units if they have a really significant problem. But generally, just by keeping our equipment in the room, over time, the level of gases in that room will go down to near zero. Maintaining room integrity suggests sealing the room, making sure that there's no leaks under the doors, using double doors when possible, checking under the false floor and above the false ceiling to make sure there's no leaks there. We see a lot of leaks in holes into the room for cabling. Of course, data centers require an immense amount of cabling, and there's holes needed to bring that cabling into the room, but then the hole itself is not properly sealed. So a lot of contaminant gases are coming in that way. Pressurization, an important aspect of pressurization in our industry, particularly in this data center and control room discussion, is ACH, or air changes per hour. We can often get the room where we need it to be in a corrosivity level, which is 3 to 6 air changes per hour by using our equipment. However, the standard, the ISA standard I alluded to earlier, does call for 12 air changes. We've seen in some pharmaceutical manufacturing or semiconductor manufacturing, they are calling in their specifications for as much as 20 air changes per hour. So what that means is that the more air changes per hour, the larger the equipment is, the blowers have to be larger, and you're moving that many more cubic feet per minute or cubic meters per hour of air through our equipment. So generally, more air changes per hour is associated with a higher cost. However, that higher cost definitely translates into a cleaner room and much less corrosivity in the room. And then ongoing monitoring of the room with our ECM, rather than relying on just this corrosivity test kit for 30 days of readings, checking for constant 24/7, 365 monitoring corrosivity in the room via the ECM. Talk about the basic design requirements in the room. If you're working with a room designer, or you already have a room and you're having to retrofit our equipment into an existing room because of a gas problem that you've noticed, these are what we're trying to do to get the room to be as low a corrosivity level as possible. So Pure Air staff and or our local representatives in your area will come in and essentially survey the room and look for these types of parameters: the humidity, the temperature, how many people are coming in and out of the room every day. Is the room tight? Are there any leaks? Are there cabling holes? The doors, are you using double doors? What have you? But this is important for our customers to understand, because these are the questions that we're going to be asking. Let's talk a minute about the media that we use in our equipment in the data center application. So I'm guessing 99% of our customers in data center and control room applications are using the PP blend media. I've seen where some people have some people have asked for our CPS blend or our CPS 12 blend. However, this seems to be the real Iron Horse media blend for the data center application. So we have 50% of PP blend is our pure air 8 potassium permanganate KMNO4, and 50% is our newer Sulfasorb 2 product, which is a fantastic product that replaces our longtime Sulfasorb. And the reason we have Sulfasorb 2 in here is that it is UL certified, and there's absolutely no risk of fire because both the KMNO4 Pure Air 8 and Sulfasorb 2 are based largely on alumina substrate, so there's very little risk for overheating. Great product. Here's the two components split up: Pure Air 8 and Sulfasorb 2. Again, on our website, or if you email me, I can send you the spec sheets for both of these. But these are, in and of themselves, great products in their applications, and then combined together 50-50 to make PP blend. Really a fantastic product, and gets the room down to G1 very, very quickly. Another slide about Pure Air 8 and Sulfasorb 2. And these two together equal PP blend. Note the UL certification. Critical for these types of applications, particularly if this product is used outside in an oil refinery, gas refinery. Those customers demand that it's UL listed. Here's what I see are trends in the data center market after visiting literally dozens or hundreds of customers in this area and attending the trade shows and meeting hundreds of experts in this area. Here's what I see is the trends for our customers in the use of our products. So a lot of our products are being retrofit into existing data center systems, but certainly the trend is designing gas phase filtration into the newer rooms that haven't been built yet, but are being designed or are being built right now. So we're being called in the very beginning part of the process to discuss how we can have our media and airflows pushing the known contaminant gases through our media as the room is being designed. Another trend right now are that customers are understanding that the pollutants that are outside of their buildings that are getting pulled in to the data centers and the control rooms are affected by seasonal activities. And of course, by seasonal, that could be spring, summer, winter, fall, like that, but it has more to do with the wind changes. What are the neighbors' factories producing? Is a neighbor factory running a different process in October, November, December than it is in June, July, and August? And the pollutants that are run in that process are different, and certainly wind changes could blow those effluents over into your building at a certain part of the year, but maybe not so much in another part of the year. So there's quite a bit of study of the environment like that. We certainly see in Indonesia and some other countries a lot of crop burning at certain times of the year. That crop burning produces a lot of problem gases and pollutants and smoke and what have you for certain areas, and those customers are greatly bothered by that and are worried about equipment being shut down because of that crop burning activity. In the Philippines and some other places, we see volcanic activity. Of course, it's not predictable, but nonetheless, the volcanic activity is not constant, and it can flare up and produce a lot of H2S, NO2, SO2 at varying times, and depending on the winds, then it could be a bigger or lesser problem for our customers. I see many of our customers starting to deploy sensors outside that trigger higher levels of purification, potentially even more air changes per hour as the outside sensors are picking up higher levels of H2S or SO2 or NO2. And I think that that is a trend that's going to really pick up next year and in 2024. And then I see more airflow sensors being deployed throughout the server room. As I mentioned earlier, the corners of the room and behind the racks can be quite dead in terms of airflow. And so we are recommending to our customers to just put some simple fans there to move that air through the corner where the gases could be trapped, and certainly behind the server racks where there's very little airflow, just get some fans moving the air back there. But nonetheless, I see airflow sensors being deployed throughout the server rooms to make sure that air is actually moving and any potential bad gases are being moved out of those dead spaces and eventually getting pushed through our equipment to get purified out. Solutions. Again, when Pure Air staff, me or our agents or representatives come and meet with you to look at your room and do a survey, these are the types of questions that we're going to be asking and trying to understand as much detail as possible. So the type and level of contaminant is obvious. Of course, we want to know, is it H2S, is it NO2, is it SO2? Maybe you don't know, and it's quite possible you don't have the capability to figure that out, but we can, and we can work with some air testing labs to figure out how much you have in terms of these problem gases. And if it's seasonal, we'll work with that, talk to you about the wind flow around your factory, what the neighbors are up to, what they're producing. And it could be a neighbor that's as much as 1 kilometer or more away. I just saw a very interesting application at a steel mill in Pakistan, where there's a coal plant about 1 kilometer to 1.5 kilometers away from our customer. And because of the wind, that coal plant was pushing effluent directly at our customer's inlet air handling unit and causing all kinds of problems in their control room. So we're able to help them and get that under control. Temperatures and humidity. Again, if you have a crack, or CRAC is a computer room air conditioner, you'll understand this, and the crack will handle a lot of that temperature and humidity for you. But if you don't have that, then we need to understand the relative humidity and average temperature in the room. And that could vary depending on the season and the time of day. And as we talked about earlier, we'd like to get temperature as much around 21, 22 degrees C as possible, and humidity right about 50%. So we will ask you about that. Of course, volume, frequency of airflow, and the room size does not just include the floor space. We need to know the total volume of the room. So from floor to ceiling, and in a data center, that usually means the floor underneath the false floor and the ceiling up above the false ceiling. So there's usually another meter to add in that height dimension above the false ceiling and below the false floor. So we like to know all of that, the types of equipment that are in the room, the building construction and controlled spaces, what is the pressurization and recirculation capability of the room? Are there any space restrictions in the room or outside of the room? For example, if we need some really large equipment, we would probably put it outside of the room. People flow, meaning how many people are coming in and out of the data center every day, opening the doors, potentially sucking in bad air from outside of the room. through that venturi effect of opening the doors consistently. So we like to know if it's one person coming in one time a day, or if there's as many as 100 people or 100 door openings per day. Particulate filtration, as I talked about, that's quite critical, and we need to understand what you have deployed in the air handling units for your particulate filtration, and then continuous monitoring of air quality, environmental conditions, and the corrosivity of the room, either through our corrosivity test kit, the coupons, or our electronic corrosivity monitor that's doing it 24/7, 365. Okay, here's my contact information. Again, we'll be sending out these slides, so you don't have to frantically write this down, but this is how you find me. Don't worry about where I am at any given time. If I'm in Asia or where, you can contact me by email or through any of these messaging applications.